Alright, so here is the half sheet video for building polynomials. This is review for your building polynomials quiz. So what we have is that we're going to start with 3 different graphs, and we're just going to write the equation of these graphs in factored form. Alright, so you have to note the multiplicity and then what sign the leading coefficient would be based on what the end behavior is. So for number 1, I start with a root at -3. Now, if I have a root at -3, remember the factor has the opposite sign. So our factor would be x plus 3. And because the graph comes down and bounces off the axis, it has a multiplicity of 2. The next root is at -1, and the factor for -1 is x plus 1. And finally, I have a root at +4, so my factor is going to be x minus 4. Now, because this graph looks cubic through the root, it has a multiplicity of 3. This graph, the number of turning points would be 1, 2, 3 turning points. Now, the likely degree here, yes, you can go based off of the turning points, but count the multiplicities that you wrote in your factored form. I have 3, 1, and 2. Well, 3 plus 1 plus 2 is 6. Now, we didn't go over this in class, but the classification, the name for a degree 6, is either called hextic, like a hexagon, or sextic. Let's see. But hextic kind of makes sense here, and you don't need to know that. It's just I'm throwing that on there for you. All right, number 2. Oh, and I'm sorry, because both arrows are pointing up towards positive infinity, that means that the end behavior of this graph is positive, so I do not need to put a negative in front of the equation. Number 2, the first x-intercept is at -2. I write the opposite sign in the factor as x plus 2. We cut straight through the axis here and look linear, so I do not have a multiplicity other than 1. The next root is at 0. And the factor we write for 0 is actually just x. So I'm going to move this over. Write the x plus 2 here. I like to put the x right in front, but you can put it wherever in the equation you want. The other root is at +1, so our factor is going to be x minus 1. Again, both of those have multiplicity of 1 because they cut straight through the axis. Now, you should be able to see here that the end behavior of your graph is negative, which means that your graph has a negative trend, and I need to stick a negative in front of the equation. This graph has 1, 2 turning points, and based off of the multiplicity of 1, 1, 1, those add up to be 3. So degree is 3. If I have a degree of 3, that means that my equation is called cubic. Last one here. I have the root at -6, and the root of -6 writes the factor of x plus 6. It cuts through in a linear fashion, so it's multiplicity of 1. Same here at the root of -2. I'm going to write the factor of x plus 2. It also has a multiplicity of 1. The root at 0 is the factor is x. It has a multiplicity of 1. And the root at +3, I write the factor of x minus 3. All multiplicity of 1. Now, because both arrows are pointing down, that means that I have a negative leading coefficient, so I have to stick a minus in front of my equation. This graph has 1, 2, 3 turning points. The degree based on my factored form is 1, 2, 3, 4. So it is called quartic. Good. Go ahead and flip your half sheet over. Now on the back, we're going to be given the roots, and you need to write the factored form. So it tells you here that our equation, our standard form, will have a degree of 3 when we're done, and we want you to create it so it has a positive leading coefficient. Now, what I'm giving you in this function notation here is that there's an x-intercept at 2, an x-intercept at -1, and an x-intercept at 2/3. So from those x-intercepts, in order to get to standard form, we have to start with factored form. So you take the opposite of the 2 there. So the opposite of +2 is -2, which will be your factor. We only have it listed one time, so it has a degree of 1, multiplicity of 1, I'm sorry. The factor of negative, or the root of negative 1 gets a factor of x plus 1, multiplicity 1. And here, when I have a fraction, remember I slide the 3 up in front of the x, and you take the opposite of the numerator. Those roots all show up one time, so they all have multiplicity 1. Well, this is factored form, but we're looking for standard form. So my suggestion for you, I like to start on the right, but you can start wherever you want. I'm going to distribute those two factors together from the right. So I'll start here. 3x times x is 3x squared minus 2x plus 3x minus 2. Then I bring down the x minus 2. We're not done with that. Well, I need to combine like terms here. So I'll have 3x squared plus 1x minus 2. And what I'm going to do is I'm going to multiply that trinomial by x minus 2. When you do this, the x gets distributed to every term. So we'll start by getting x times 3x squared is 3x cubed. X times 1x is plus x squared minus 2x. And then you also need to distribute the negative 2 to every term. So negative 2 times 3x squared is negative 6x squared minus 2x plus 4. Now to get your standard form, your final answer, you're just going to combine like terms. Nothing combines with 3x squared. I have 1x squared minus 6x squared is negative 3x cubed minus 5x squared. Negative 2x minus 2x is minus 4x, and then plus 4 on the end. That's your standard form. Now check. Does it have degree 3 like we wanted? Yes, we do. Does it have a positive leading coefficient? Yes, we do. So we have the characteristics we looked for. Now to sketch your graph. We're sketching a graph based on your factored form. So you're looking right here at this factored form in order to make your sketch. Now you know that there's a root at 2, so you can label 2 on your graph. You know there's a root at negative 1 and a root at 2/3. So I'm actually going to stretch this out just a little bit. Root at 2 and a root at 2/3. So we have a positive leading coefficient, so with an odd degree, that means that you're going to start low and end high. And everything has a multiplicity of 1, so it means we're going to clearly cut through each x-intercept. So if I start low here, I'm going to come up and cut through negative 1, come back down through 2/3, and back up through 2. That would be your cubic polynomial. All right, one more. All right, I have x equals 0, x equals 0, x equals 0. Well, by 3x equals 0, the factor that I write for x equals 0 is going to be x. But because it shows up 1, 2, 3 times, that means the root has a multiplicity of 3. Then, if I have the factor, or the root, x equals negative 4, well, its factor will be x plus 4. I have 2 of them, so it has a multiplicity 2. Well, let's see. It's suggested that we need a degree of 5, which is what we get here. 3 plus 2 gives me degree 5. A negative leading coefficient means that I want to stick a negative in front of that x cubed. That's your factored form. Now we have to come up with standard form. Before you can distribute the negative x cubed, you can't do that yet. You have to deal with the x plus 4 squared. So you need to rewrite this as x plus 4 times x plus 4 and multiply that out first. When you do that, you'll get x squared plus 4x plus 4x plus 16. Now, the 4x's here, they're like terms. Those combine. So I'm actually going to erase this and rewrite that as x squared plus 8x plus 16. Okay, just to save some room, but that's what we combine to be. Now this negative x cubed comes down. Okay, we keep it there. We're not using it yet, but now we can. Now I can distribute negative x cubed to all 3 terms in my equation. So that'll give me negative x to the 5th minus 8x to the 4th minus 16x cubed. That's your standard form. That is what's going to go on your line here. Now let's double check though. We have what we need. Degree 5. Yep, got degree 5. Negative leading coefficient. Yes, I have that. So let's talk about this graph. Plot your x-intercepts. We have a root at 0 and a root at -4. All right, I have an odd degree, which means my arrows go in opposite directions, and a negative leading coefficient. I have a negative trend, so I start high and end low. When I start my graph, and when I come down to the -4, because it has a multiplicity of 2, I'm going to come down and bounce off of that root. That's what a multiplicity of 2 looks like. Now at 0, I have a multiplicity of 3. So I'm going to come down and look cubic through that root, which means that you flatten out when you get to the x-intercept and continue going straight down. That is the sketch of your 5th degree polynomial. All right, make sure you understand that. If you need any more practice, go on back to the practice that we did in class on Monday, or go back to your notes from Friday and see if there's any problems that you didn't do to give yourself some extra practice.